Welcome back to session 11 of GED Advanced Graphs and Functions. Today we solve systems of two linear equations, nice and slowly. A system is just two lines on the same grid, and the solution is the one point where they meet, the point that makes both equations true at the same time. We will find it on a graph and also with algebra, one small step at a time. Let's be very clear about what we are looking for. A single equation has many solutions, every point on its line. But a system asks for the special point that lies on both lines at the same time. That shared point makes both equations true together. There is usually exactly one such point. On a graph, the solution is simply where the two lines cross. So plot both lines carefully and look for the exact point where they intersect. Read its x-coordinate and its y-coordinate. That ordered pair is your solution. If the lines are parallel and never cross, the system has no solution. We can also solve without a graph, and it is very reliable. When both equations are solved for y, the two y expressions are equal at the crossing point. So step 1, set the two expressions for y equal to each other. For y equals x plus 1 and y equals negative x plus 5, we write x plus 1 equals negative x plus 5. Now solve that equation for x, one step at a time. Start with x plus 1 equals negative x plus 5. Add x to both sides to get 2x plus 1 equals 5. Then subtract 1 from both sides to get 2x equals 4. Finally, divide both sides by 2 and x equals 2. We found the x-coordinate of the crossing point. We have x equals 2, but a solution needs both coordinates. So substitute x equals 2 back into either original equation. Using y equals x plus 1, we get y equals 2 plus 1, which is 3. So the solution is the ordered pair 2, 3. Always give both numbers. Here is a habit that guarantees accuracy. Take your answer and check it in both equations. Put 2, 3 into the first. 3 equals 2 plus 1. True. Put it into the second. 3 equals negative 2 plus 5. Also true. Because it works in both, 2, 3 is definitely the solution. 3 traps to avoid. First, never give just x or just y. A system solution always has two coordinates. Second, read the intersection carefully. Do not swap the x and the y. Third, remember that parallel lines never meet, so that system has no solution. Finish every problem with a check. Let's lock it in. A system is two lines, and the solution is the point they share. On a graph, that is the intersection. With algebra, set the y expressions equal, solve for x, then substitute to find y. Always write both coordinates and check them in both equations. Systems solved. Great work today. You can now solve a system by graphing and by algebra. Your mastery check is the 10 practice questions for this session. For each one, find the intersection, then check your point in both equations. To read the full lesson notes and practice more GED graphs and functions questions, visit the course page at www.bridgetoexam.com. I will see you in session 12, where we shade linear inequalities. Keep going, you are doing great.